Hi, my name is Jeffrey,
Hi, my name is Amit.
Hi, my name is Chris.
And my name is Philip.
and this is the Yellow Jacket Disinfection Solution. Around Georgia Tech, there are two primary bus types and many different bus routes. With the trolley, students, faculty, and even strangers ride from MARTA Station to Tech Square. While on campus, people can use the Stinger buses to travel. However, following the recent outbreak of COVID-19, buses are forced to be disinfected constantly in order to keep passengers safe. This consequently hampers the freedom of the buses. Because of the pandemic, in fall of 2020, Georgia Tech plans to increase service frequencies of the gold and blue routes as seen on the map, at the cost of the red route, Midnight Rambler, and weekend gold route services. The blue, green, and Tech Square routes will resume service by August 17, 2020. Therefore, Georgia Tech needs to find a way to increase the efficiency and reliability of transportation disinfection in preparation for the returning students and faculty, as students, faculty, and others often utilize the transit system for their individual needs.
So through our thorough research about transit systems, we found several notable facts about disinfection methods used, such as UV lights and how the pandemic has affected people's daily commute. First, we found out that essential workers and people with disabilities rely on mass transit systems to get to and from a place. Next, we discovered that New York and Shanghai have implemented UV light systems in their subways and buses. The reason they did this is because UV lights have been effectively used in the past to kill viruses, bacteria, and infectious diseases. Aside from the effectiveness in killing coronaviruses, we found out that UV lights only take about 5 to 7 minutes to fully disinfect a vehicle, and so are faster to use than normal cleaning methods. However, UV lights come with a few drawbacks, and the most notable is that they can have high installation cost and can be dangerous if exposed directly on human skin. Although UV lights can be expensive to install initially, the benefits that occur with its usage over time is tremendous, because it can be used to fight other infectious diseases in the future. In terms of danger if exposed on skin, current UV light systems are only operated when everyone is off the vehicle. To address this issue, several scientists from Columbia University are developing a new technology known as far UVC that will make operating UV lights safe to use on human skin by reducing its wavelength. In the future, far UVC lights can be implemented in our current solution so that disinfecting these transit systems can still take place without the expensive time. So for our questions that we asked to interviewees, we asked several questions. So we asked, what are the primary ways they plan on commuting? How often they use MARTA or other mass transportation systems before COVID-19? How comfortable they would feel inside a taxi or transit system right now? And appropriate protective actions they think they should take themselves, and what else they think other people should implement? And whether they think that using UV lights or disinfecting fog would be better. So for our customer interviews, we decided to send out a Google Forms survey to tech students so that we can hear what current students have to say. We received a total of 19 responses, and here are a few visuals representing the overall data. So in the bottom left pie chart, before the COVID-19 pandemic, you can see that most students, about 63%, have used mass transportation systems at least a few times per month. Next, in the top right chart, there's about an equal number of people who said that they would prefer using a bus or a taxi. This includes when asked about things like safety, cost, and time required to travel. Lastly, in the bottom right pie chart, most have said that they would prefer a UV solution rather than disinfectant fog because they think that UV lights will be more effective in killing the coronavirus. Others have added that they would feel safer with the UV lights because they may perceive the fog as some dangerous gas.
After we committed to using UVC light as a method of disinfecting the interior Georgia Tech's trolley and Stinger bus systems, we then began drafting concept designs of a static solution that resembles an array of single-mounted UVC lights that are connected in series, as these would be lined along the interior of the bus, as seen in the sketch, where the end connection would be linked to a designated power source near the bus stops across campus. However, as we searched for the cost of these UVC fluorescent light fixtures, We noticed that these fixtures cost from a few $100s to around $1,500 according to Larson Electronics. However, replacement bulbs can be purchased for $59 on Grainger Industrial Supply. Where, with this critical piece of information, we shifted our focus towards a more portable and inexpensive solution and discussed if there was a way for us to improve upon our current system by making it a handheld device. But due to the lack of constant exposure to UVC light for a set period of time and the consideration of human error, we then shifted our focus again with coming up with a solution that was more reminiscent of hospital models, yet more cost-effective, since the cost of these models vary heavily and can range upwards of to $20,000. We sketched out a concept design of a UVC light tower within a bus, then constructed a homemade model based off of this prototype to help see physical design flaws and areas of improvement, such as the size of the base and the length of the light bulbs. We fixed our imperfections by virtualizing our design into a 3D model in Blender, which serves as our most precise form of our prototype design.
Our final design is a tower of 4 UV light bulbs, standing about 5 feet tall. Each tower can be connected to another to create a series of towers powered by a single source. This design took inspiration from systems that are already used in hospitals and on the Shanghai subway and bus systems. Each bulb will be a low to medium pressure bulb to maximize electrical efficiency, and will emit a UVC light at 254 nanometer wavelength for about 15 to 20 minutes, causing complete cellular breakdown and subsequent death of 99.99% of bacteria and viruses. This system will be easily movable and will be placed inside the bus after each trip at a designated area along the bus's circuit. The system will be taken out of the bus after that bus has been disinfected and will be placed in the next few systems will be disinfected, so that only a few systems will be able to disinfect multiple buses.
Here's a list of references if you want to learn more about the topic. And yeah, thanks for watching.